Somewhere in a network, a mistake can happen. Two routers, each convinced the other one knows the way, send traffic back and forth between themselves forever. Today, we look at the one rule that stops that from ever mattering. Without a fix, a packet caught in a loop like that would never stop moving. It would consume bandwidth, occupy router memory, and never, ever reach anyone. The fix is almost absurdly simple. Give every packet a number the moment it's created and force that number to shrink every time it moves. That number lives in a single byte in the packet's header, called time to live TTL for short. It typically starts at 64. Every router the packet passes through does exactly one thing to that number, subtract 1. No negotiation, no exceptions, every single hop. In an ordinary, healthy delivery, the packet reaches its destination with plenty of countdown left to spare. The number barely matters. But trap that same packet in a loop and the countdown becomes the whole story, hop after hop after hop, ticking towards 0. A birth number, a tick at every hop, a death at 0. Let's follow one packet through that entire countdown in slow motion. Take one, picture a small misconfiguration. Router A thinks the way forward is through router B, and router B thinks the way forward is back through router A. A genuine routing loop. Without any safeguard, a packet handed into that loop would circle endlessly. No error, no timeout, just wasted capacity forever, multiplied by every packet unlucky enough to wander in. That exact scenario is precisely what TTL was invented to guard against decades ago, in the very first designs of the network we still use today. So follow an ordinary packet instead. A sender creates it, say, your laptop asking a distant server for a page, and hands it off to the network. The moment it's created, the operating system stamps a TTL value into its header. 64 is common. Some systems choose 30 or 128 instead. The packet leaves carrying that number with it. Router 1 receives it, forwards it toward its destination, and before doing anything else, subtracts exactly 1. 63, router 2 repeats the exact same ritual, receive, forward, subtract 1. The packet has no idea whether it's hop 2 or hop 20. 62, then 61 at router 3. Every router along the path performs this same tiny bit of arithmetic, completely independent of every other router. In a healthy path like this one, the packet arrives with dozens of counts still left. The countdown ran the whole time, it just never became the story. Now rewind and put that same packet into the loop from earlier instead. Hop after hop, the same subtraction happens. 63, 62, 61, and no destination in sight. Eventually, inevitably, the number reaches 0. At that instant, whichever router is holding the packet is required to stop. No more hops, no more chances. That router discards the packet immediately. Not queued, not retried, simply removed from the network, forever ending its pointless journey. One rule, running independently at every router with no central coordination at all, guarantees that not a single packet can loop through this network forever. The dropping router doesn't stay silent. It sends back one small message, an ICMP time exceeded reply addressed to whoever originally sent the packet. That reply carries a priceless clue. The address of the exact router where the countdown ran out, proof of precisely how far the packet actually traveled. A whole diagnostic tool is built on nothing more than that clue. Traceroute sends packets with TTL 1, then 2, then 3, collecting a time-exceeded reply from every router along the way. IP6 keeps the same idea under a different name, hop limit, and the logic is identical, one less at every router, gone the instant it hits 0. Born with a number, reduced by 1 at every router, discarded the moment it reaches 0. One tiny counter and no packet can ever loop through the network forever. Thanks for watching. Next time you run Traceroute and watch it list router after router, you'll know a shrinking countdown made that list possible. Check out our other videos and follow how it all runs for more. See you in the next one.